Hi everybody, welcome to my talk. I'm here to talk to you a little bit about Apache Spark. So Apache Spark is a leading technology in analytics, machine learning. It's faster and easier to write than Hadoop. You've got machine learning at your fingertips, and it does seem like everybody's using it right now. It even has an SQL-compatible API, and you don't have to learn functional programming, although I know no one here would ever pass upon a chance to use functional programming. So it can make all these awesome things possible, and especially if you're working with a database like Cassandra or another distributed database, it starts enabling operations that otherwise would be impossible. For example, you can start doing joins on data in a system which does not support joins. But the question is it the right system for you to use for your particular organization? Because there's cost associated with every technical choice we make. And today I'd like to really analyze that and go over what Spark can do, what it can't do well, and what other options you might have. So I'm talking about this because I, Russell Spitzer, a software engineer, have been working with Spark and Cassandra for quite a while now. I think it's about 5 years. I've been working on Spark since Spark 1.0 came out, and at Cassandra since Cassandra 3.0 came out. And I work on one of the teams that works on the Spark Cassandra connector, which is the tool that allows you to take data inside of Cassandra and have it interop with all of your different Spark analytics and things like that. And I've learned a lot of things over this time, and I've seen a lot of use cases that work really well for the two of these technologies together, and a lot of use cases which don't work so well, and I'd like to encourage people to use other technologies in those places. So to start, let's talk about what are the really big use cases for Spark. So in my mind, Spark has these three major use case classes. There's analytics, that's asking really big questions about your data. It's asking, what did every user do last year? What are the patterns in my data over year for every single user? And this is opposed to small questions, questions like, what's in this user's shopping basket right now? What did this user do yesterday at 5 o'clock? So those are very small, what we call OLTP questions, as opposed to the big questions, which is, what did he do all year last year, which is more of a big data analytics sort of question. Then there's ETL. That's taking data from one system and moving it to another. So that's an acronym for extract, transform, and load. So for example, taking your data from MySQL and moving it into Cassandra, or taking your data from Cassandra and moving it into Parquet files somewhere. And then finally, a use case of streaming, which is live data coming in and needing to be processed as it arrives and getting some kind of business insight from that data. So data that comes in live. For each of these use cases, we'll go over the pros and cons and some alternatives. So we'll start with talking about Spark for SQL and analytics. So why would we care about Spark for SQL in the first place? Well, lots of us use databases like Cassandra, which do not support a lot of basic SQL semantics. So for example, as I said before, Cassandra cannot do joins. It's just not something that is intrinsically fast to do in a distributed system built like Cassandra. So it's basically forbidden from the outset. There's no way in the language to even do a request that joins between two tables. But Spark allows us to do that sort of operation without any added complexity. Basically, once we have attached Spark to our Cassandra data, we can start doing joins, although of course not at the same latency and response that we would expect from a normal Cassandra request. In addition, we can start doing all sorts of aggregates, other sorts of things where we look over all of the data in the database at once, which might require actually doing processing on several different machines because the data set is so large. And in addition, we might have business intelligence tools. You might have something like Tableau or even Excel, which are able to connect to databases as long as they have a JDBC endpoint. And Cassandra, since it does not support ANSI SQL, does not support a JDBC endpoint. But Spark can provide one of those for us. And again, of course, any custom logic you might have. So big questions or custom code. Maybe you have a Fortran library sitting in your basement and you need that to run on your Cassandra data. Well, Spark's a good way to get your data into a place where you can run your Fortran code on all of your Cassandra data at once. So how can we use Spark to do SQL and analytics? Well, we have a lot of different options. I'm going to start with what I think is the easiest option, which is something that comes bundled with all Spark installs, which is called the Spark Thrift Server. I'm going to do a quick shout out that DataStax provides something called the Always On SQL Server, which is built off of this technology and basically is the same thing, but in a HA environment. And the thrift server basically provides a JDBC endpoint that's backed by Spark. So any sources that Spark can talk to, the Spark thrift server can provide as a JDBC endpoint. So basically, if you connect your Cassandra data to the Spark thrift server, you now have a JDBC endpoint for all of your Cassandra data. So it's a really useful tool if all you really need is an SQL API onto Cassandra data. This works for, of course, all of the BI tools that I mentioned before. Now, outside of that, we have programmatic access to Spark, and that comes in a whole bunch of different APIs in different flavors. I've highlighted here the two main APIs you probably are going to care about are data frames and RDD. If you are just picking up Spark now, you probably will never use an RDD. And data frames is probably going to be the most common thing. It's available in a whole lot of different languages, Python, Scala, Java, R. And within all of these different language bindings for the data frame API, you actually will get the exact same performance. So it's really excellent if you start out with Spark, you go into data frames. In addition, you can do interactive work in Spark using shells. There are shells available in Scala and Python and R, as well as notebook environments, so you can actually test out code and run it in a live notebook environment on all of the data that you can connect to Spark. So that's pretty cool. So this code actually looks pretty interesting. So I've got examples here of the data frames and RDD APIs. The data frame API is on the left there, and what you can see is basically to do an operation in data frames, you describe what you want the data to do. Now, the top few lines are describing how to read the data, basically saying that I'm reading data out of a Cassandra type source, and then there's some specific options that are Cassandra specific, a key space and a table name, and then below that, I describe the operation I want the data frame to do, and in this case, I just wanted to aggregate a column called amount with a sum. So basically, just sum together all of the values in the amount column. And right underneath that, I've shown the SQL variant of that. So if you do the top box or the box right below it, they actually will do the same work under the hood in Spark. So it's really awesome that you can actually use a simple SQL API to do the same thing as you can do in a programmatic language. And what you'll notice there is that in this API, we don't actually describe what kind of objects we're reading out of the database. We don't describe how to actually do addition. We don't describe how to shuffle the data together so that it's arranged in the right places. All we do is describe what we want. And what we want is the sum of the column amount. Now, on the other hand, the RDD API is the first API that came out with Spark, and it's a bit more low level. It's where you describe exactly how your objects are being manipulated and what operations are being done to them. You'll notice that in order to get the amount column out of this Cassandra table, I actually have to say that it's an integer. I have to use a getter. I'm actually getting out a Java integer in that function. And in my reduce, I actually have to explain how to add things together, because this is raw code. I basically have to say this is the implementation for taking two values and combining them. So it allows you to have a much lower level operation, but it also becomes unoptimizable. The data frame API, all the code that will be generated by this under the hood by Spark will be optimized and will probably not use any Java objects. It'll actually work on unserialized byte data. So it's much more efficient to use the data frame API, but the RDD API still exists, so you might see it sometimes. So what are the benefits for using Spark for this kind of work? Well, both of those code samples I showed you before will automatically make use of distributed computation and distributed reading, which means we don't actually have to define the fact that Cassandra is a distributed database that exists with data on many different machines and it's partitioned in this particular way, and to get all the data, you have to request it by token ranges. There's all these implementation details that we just don't have to know. Spark is going to automatically use the Spark Cassandra connector, in this particular case, to know how that data is mapped out, pull in the right chunks into the right machines, and do all of the work that we want. If we ask for things like a reduce, or we ask for things like an aggregation, it's going to automatically know these are the places where I need to shuffle the data from multiple machines into different places so I can do other operations. So you don't actually have to think too much about how do you actually sum data that exists on 20 different machines. All you have to do is say, I would like to sum the data that's in this column, and it will be like, oh yeah, well the right way to do that is we'll take these two machines and we'll run through the sums on each of them, and then we'll combine those sums and run through sums and combine, and it'll figure that all out for you. So you don't actually have to think about the implementation at that kind of distributed level. In addition, this data frame API, not the RDD API, but the data frame API, will take the expression that you wrote and try to optimize it into something that works a lot more efficiently, as well as generating custom Java bytecode that will hopefully do your operations much faster than you could ever write yourself. And in addition, it has this data source API, which various vendors are able to implement their own connectors for. So the reason that the Spark Cassandra connector can be implemented or can be used in this code in a single line is because of the data source API, which just says if you provide a format like this string, and all the implementation details, any end user can then use that source to connect to your particular database or queue or file system or whatever it is. So it's got a lot of great benefits for interoperability and doing distributed work. But there are some downsides to using Spark. Now, one of the main things I think that's a downside in all use cases for Spark is that this is a brand new application framework and a brand new technology that you have to introduce. So that means that you actually have to get a lot of people up to speed on a rather large new framework that if you are managing it in-house, you also need to dedicate someone to managing all those resources. A good way around that is using a cloud-based hosted Spark platform, something like Databricks' Cloud or AWS's EMR or Dataproc from Google. There's a lot of different services. But you basically still need someone who knows how to set up that layer of connecting your programs to the cloud. So you basically add on a bit of burden to actually get a lot of this up and running. And the other problem is that all of these operations and all of this code is optimized around distributed computing, which means if you're doing something that does not require distributed computing, it can be done on a single machine, this will almost always be slower than doing it on a single machine. So Spark is generally not the answer in that case. So what other options do we have if we're not using Spark to do big analytics questions? So if we are working with lots of data, and I just listed there's a couple competitors to Spark, Flink, Presto, Hadoop, all of these are different large big data frameworks that will let you read data from big distributed sources and do really large operations on them. If you have any of these already in-house, I would always suggest going with a technology that you already have expertise in rather than introducing a new technology just because it's fun, although that it is fun, so you might want to do that anyway, but you know, your mileage may vary there. And if you're using Cassandra, one of the things that you can think about, and this is also applicable to a lot of other databases, is sometimes you can remodel the way your database holds your data in such a way that your big questions are now small questions. So, for example, you might take running aggregates as your data is being ingested so that you can actually look up small sub-aggregates rather than reloading the entire data set to answer the same question. So, for example, in Cassandra, you can do queries on a single Cassandra partition that involve aggregates. So as long as all your data for your aggregate exists in the same Cassandra partition, you don't actually have to introduce a new framework to do an aggregate over it. If you have a small amount of data, I can't help but emphasize how important it is to use single machine libraries and single machine systems when dealing with small amounts of data. It's almost always faster, it's much easier to repeat, and your overhead for working with it is much lower. So things like R, Python, or even awk scripts. I spent a lot of time during my PhD doing processing of data files that were a few hundred megabytes, and it almost always makes more sense to write a quick awk script to process a file than it does to spend the time to actually think about how I would distribute this to a lot of different machines and all that. 600 megabytes was a lot more memory when I was in grad school than it is now. So try to keep that in mind. Anyway, so those options look a little bit like this. This is just an example of doing an aggregate in Cassandra using a Cassandra aggregation function. As long as my race points are within the same Cassandra partition, I can do an aggregation over them. There's an article here by Adam Drake, which I really like, called Command Line Tools Are 235 Times Faster Than Your Hadoop Cluster, which is a little bit of a tongue-in-cheek example, but he basically shows that he can do a small, I believe it's a Python script that does the same aggregation work on a file that's several gigabytes large that takes a Hadoop implementation 10 minutes just to get started. Because there's a lot of overhead in setting up tasks and distributing data over the network and getting the data back and writing it to HDFS and back and forth. So it definitely pays to think about how big is the task you're working with. And what do you need to do with it? And of course, for SQL, Flink and Presto also have SQL APIs, so if you already have those in-house, you don't need to switch to Spark to get that API, so consider those as well. So now that we've got a bit of the pros and cons, should we actually be using Spark for SQL and analytics for our particular use case with Cassandra or other databases? I have a couple questions here, and if you answer yes to a few of these, that probably means Spark's going to be helpful for your use case. So for example, do you have a large amount of data? Does your data span multiple machines, and do you need to work with all of it to answer a particular question that's important to you? Do you need a JDBC endpoint for BI? This can be a really big selling point for a lot of users if you're providing your database as a service to a set of non-technical users who just want to connect to Tableau, and they're very good at Tableau, they're very good at Excel, and you just need a way to expose your data to them. Is Spark already in your stack? If it's already in your stack and you have big questions, it's almost a no-brainer that you should be using it as well for working with Cassandra and using it with your other distributed systems. And finally, do you have multiple sources or syncs for your analysis? Are you combining data from Parquet files or log files with data from Cassandra, with data from MySQL, with data from Oracle? Because if you are doing that, Spark is extremely good at interoperating between different types of data sources and data syncs, which brings me to our next major use case, which is using Spark for ETL. So ETL, or extract, transform, load, is basically the idea that we have data in a lot of different places, and we would much rather it would all be in one place because that's where we like to do our work. So for example, you might unfortunately be in the circumstance where you've got business data in Cassandra, but you have records that someone else is processing and producing for you in Parquet files, somewhere in HDFS, and at the same time, you've got a catalog in MySQL that you have to compare the results to, and then maybe you need to actually publish this all into a Kafka queue at some point for some other service to consume. The cool thing about Spark is that Spark provides an API that lets you connect all of these different things, and that's, as I mentioned before, something called the data source API. So this is where the Spark Cassandra connector lives. This is the tool that we work on at DataStax, which connects Cassandra and Spark. But there are also data source readers for Parquet files, for CSV files, for JSON files, for MongoDB, for MySQL. Basically, if you can name it, there is a connector out there for it that implements this API. And the data source API, unlike the RDD API, is only available in data frames. And you can use it in Spark SQL or Scala, Java, or Python inside of data frames. And to show you how easy it is to switch between different sources or combine different sources, I've got a little example here. So we have two blocks of code here. On the left, we have reading data out of Cassandra and writing to a Parquet file that's stored in S3. On the right, we have reading from a CSV file and writing to Cassandra. So we have two extremely different operations, but if you'll notice, both of them basically are the exact same code pattern. We say read, we say format, and our format says what kind of source we're using. We might pass some source-specific options, but then we say load. And then to do the write, we basically do write, format, we can do options if we have them, and then save. So basically, to change this code from from reading from a distributed database to writing to a S3-backed distributed file, to reading from a CSV in DSCFS, which is our local HDFS variant, and to a Cassandra database, really just means changing the contents of these function calls. We change the formats around, we change the options around, and everything works together. We don't have to talk about the fact that, well, Cassandra's got data in a tabular format that uses specific Cassandra types, and Parquet obviously doesn't use those exact same types. It uses slightly different types, and it has a much different written format. Spark knows all of that for us, and this also will all work in a distributed context. All the readers will be distributed, all the writers will be distributed, so we didn't have to think about any of that. All we have to think about is where we're taking data from and where we're putting it to. So what are the benefits of using Spark for ETL? One is that it is extremely popular. Like I said, there are basically connectors, data sources for almost any database or streaming service or files format that you want to work with. So you can take all of those different sources of data and combine them together and do analytics or whatever you like to do on them and move them between each other without a minimal amount of code. Like I showed you, the code is pretty simple, and switching between sources really just means switching the named connectors. In addition, like I said, everything will be distributed, and this works in with the optimization system that I talked about before, where code will be generated for you that runs much more efficiently and with fault tolerance that you don't actually have to ever worry about. So what are the downsides of using Spark for this? One of the main downsides, like I said before, is introducing a new technology requires maintaining a new framework, maintaining new clusters, and things like that. And the kind of hidden thing here is that we are restricted to Spark types once we've moved the data into Spark, which means if you're using Cassandra, you might have a Cassandra-specific type, like a UUID, which, when represented in Spark, has to be represented as a string because there is no corresponding internal Spark type. So you do have a little bit of loss of value when you take certain database or vendor-specific types and move them into Spark. And again, it's usually not that efficient for non-distributed sources. So the readers and things for things like MySQL tend to not be as well built or as efficient as the readers for things like Cassandra or MongoDB, which are natively already distributed. So reading from multiple clients to multiple servers is already kind of implicit. So there are a lot of other options if you're trying to move data around from Cassandra. DataStax provides a tool called the bulk loader, which requires no additional frameworks or code. It's a single machine library that lets you pull data out and put data into Cassandra. There's a copy command called SQL copy. And of course, you can always write your own custom single machine application, although I don't ever recommend doing this because you basically are going to do a lot of work that a lot of people have already spent time on. Here's just some quick examples of how you use those. DC bulk is just a command line tool, and the SQL copy command is just a line of CQL that you type into SQL. So for ETL, should you be using Spark? Again, we have a couple of questions to think about. Do you need to move data between really disparate sources? Are you moving things between databases that don't necessarily have an easy connection point? Are you moving lots of data? Is the data already distributed? And of course, which leading into our last use case is your data coming from a messaging queue? Because one of the cool things about Spark is it has a great integration with streaming data. So for our last main use case, we're going to talk about Spark for streaming. Should you use it in that case? So why do we care about streaming? Well, we like to deal with data as it comes in now. It's becoming less and less acceptable to deal with data only from yesterday. You want to deal with the data exactly as it's coming in and respond to that data as quickly as you can. So Spark can be used to stream with two different APIs. They kind of mirror the data frame and RDD API. So structured streaming is the new API, which mirrors the data frame API, while the old streaming API is called dstreams. And again, you'll probably won't see that as much anymore. At the moment, both of those are micro-batch streaming techniques, which means they group up many events as they come in and then process them in small groups. But both of them, both APIs have fault tolerance and checkpointing methods and optimizations built into them. Now, I, again, would recommend using structured streaming. It's the newer API. It's much more efficient, and it ties into the optimization system that already exists inside of data frames. And one of the really cool things about it is that the API looks almost exactly like the data frame API. So here I've just shown for comparison reading from a Parquet file and reading from a Kafka queue. So the only real difference between these is we change read to read stream, and the rest of it is the same. The elements that come out of this are still data frames, and you can actually still do any data frame code on them. The only problem is that there are certain operations that you can't do in a streaming context. For example, you can't just count every element in a streaming context because that would never return. You have to count by a certain window or something like that. So what are the benefits of using Spark for streaming? We have this great data frame easy API. It's got the same support for data sources that the data frame API had. And it's got lots of useful, great functions and things built in. dstreams are pretty good if you're looking for something that's extremely flexible. It has more flexibility than the structured streaming API. And continuous execution mode will probably be coming as a production-ready feature of Spark soon. And that's the idea of, instead of using micro batches, doing a per tuple-based event processing like Flink or Storm does. Again, the downsides of this are there's no SQL API for the streaming side of things, so there's no way to access this through SQL. It is micro-batch based. Again, you have to worry about setting up a new cluster and a new service that's hosting your streaming operations. And of course, you still have to care about checkpointing and backup. So what other options do you have? If you're using Kafka and you want to connect it to Cassandra, we have a Kafka connector. So Confluent has an idea of connectors, which allow you to do very simple making data from your Kafka queue go into a database, and we provide one for Cassandra. And if you're looking for per event, per tuple-based streaming right now, take a look at Flink or Apex or Storm. Those are all streaming first frameworks that started out with a tuple-based model, so you can get that low latency if that's really important for you. Here's just a quick example of the code you have to write if you want to use the Kafka connector. Basically, instead of writing any applications or things like that, you just write a little configuration file that describes where the data is coming from and where it's going, so you don't actually have to write new code or write a new program. Of course, it's limited to just taking data from one place and writing it to another. It doesn't actually do any transformations or things like that. So should you use Spark for streaming? Again, we have a couple questions that I like to think about. Are we doing really complicated transformations, something more than just taking data from Kafka and putting it into a database? Are we joining with other database sources? Are we moving this data and then combining it with data that's already in Cassandra or MySQL or something like that? If so, Spark's a good choice because of the data source API. Are we doing other business logic, or are we already using Spark somewhere else in the organization? Again, I really think it pays to take advantage of the expertise that already exists in your organization. So if people already are using Spark and are good at it, I would definitely leverage them and continue using Spark. So just to wrap up, to Spark or not to Spark, my general cons to using Spark are that it's a new technology, which means a new cost in terms of monitoring, maintenance, and training. And it's best only at distributed work. So you always have to think about the fact that you're taking on a burden by adding a new technology to your stack. But on the other hand, it's got a lot of applicability to a lot of different use cases, and it's great for working with big data. It's really optimized for working with a lot of data at one time, and it can work with data from a lot of different sources all at the same time with a minimal amount of code. So my answer to the question, should you use Spark, is just yes, because I think it's really fun, and I think the more people working on Spark, the better. But of course, your own mileage may vary, and I think it takes it really makes sense to think about your alternatives when you're about to add Spark to your project. So just as a takeaway from this, if you want to learn more about Spark and you want to learn more about Cassandra, we have a website called DataStax Academy. It's completely free, and it's got tons of videos and courses on the Spark and Cassandra integration, as well as workshops and classes and all this stuff, all for no dollars. And thank you so much for listening, and I would be glad to answer any questions you have about Spark or Cassandra or their connection. Yeah?
Let's say you have Cassandra up and running, and you're doing great with Cassandra, and you're trying to integrate some Spark, and you have sort of different levels of how committed you are to Spark, different approaches. One is sort of an ad hoc approach where you have Cassandra and you're going to spin up, say, like a AWS EMR cluster. That's one. Another is where, let's say, you have Apache Cassandra, not DataStax Enterprise, and you're going to try to have like an analytics data center in Cassandra, and you want to install Spark yourself, like one of those machines. And then I guess the other option would be like if you're actually using DSC with its Spark integration, and then you have the analytics data center, but you have that with Spark baked in from DSC. So if you can maybe compare sort of the pluses and minuses of those approaches.
So the question is about the pluses and minuses of the different ways you can deploy Spark and Cassandra together. So I think one of the key things to do in all of those situations is that if you have an OLTP application, you have some active Cassandra client-facing application, is to isolate that data center from wherever you're going to be doing your analytics work. Because your analytics reads are going to be scanning the entire table at once, which is going to take a lot of resources. And you probably want your worst case scenario to be that data center becomes responsive unresponsive rather than your OLTP data center becoming unresponsive. So I would always suggest separating that out unless you are well aware of your limits and you already have everything throttled out appropriately. Outside of that, running Spark on top of Cassandra nodes makes things a little more simple if you're using DSE because that's all managed together. If you're not using DSE, I probably would recommend running Spark in a separate cluster because the main reason that we bundle it together is it simplifies management as long as you have someone else doing all the management for you, like all the installation and the plugins and the configuration is done for you. But if you're doing all the configuration yourself, you probably are going to benefit more from being able to scale both sides separately. So if you're already taking the burden on of managing both components on your own, I would run your Spark probably on separate nodes than your Cassandra data. And if you're using EMR, I would basically just have a separate data set for doing your scans off of, or a data center for doing your scans off of. So there's benefits in terms of read performance, but they really depend on, it really depends on how your data is set up. So one of the key things is that if you've got machines that are already doing, that are not I/O limited, right? If your machines are no longer I/O limited, then you'll be fine running your machine, your Spark on the same nodes, and you're going to save on network transit as long as they're co-located. But if you're not I/O limited, if you're in fact CPU limited, then you want your Spark running on a different cluster because that's just additional CPU burden instead of additional I/O burden, and you probably are not as sensitive about the I/O between the network. So again, you really have to try it out. Big difference between running on EMR versus on-prem, especially if your Cassandra is on-prem and EMR is far away, have latency differences and all that kind of stuff. So you probably need to try it out and see what works best for you. So we have time for one more? No more. We have to wrap it up. Thanks so much for coming up. I'm always ready for talks or questions. So see you around.